Let's talk about completing the square. I have one example for us, and in this particular example, our leading coefficient is not 1. We've done some of these before where the leading coefficient was 1, and it makes it actually a little bit easier, but in this case, our leading coefficient is a 3, so we're going to have to deal with that. First thing I'm going to do is make sure that there's a blank in the constant position of my quadratic. So there is an 11 in that position. I'm going to start by subtracting that 11 over. So notice now there is nothing in the space where the constant used to be. And that's great because that gives me the opportunity to put exactly the number that I want in that blank. Now, the next thing I need to do is make sure that my leading coefficient is 1. Since my leading coefficient in this example is a 3, I'm going to divide everything by 3 to turn that leading coefficient into a 1. So dividing all 3 parts by 3, I get x squared plus 4x is negative 5. And now I go through and I fill in the blank with the number that completes the square. I take the coefficient of my linear term, so that's this 4, I divide that by 2, and that gives me this magic number that I'm going to use to factor later. So remember that 2, I then square it and I add it into the blank on that left-hand side. So 2 squared is 4, I'm adding 4 to the left-hand side of my equation. But I can't just add 4 to the left, I have to also add 4 to the right-hand side of my equation. So on the right, I add 4, and the left is now a perfect square trinomial, so I can factor. Remember that we created it so that it would factor as a perfect square trinomial, so I know exactly how it's going to factor. It's going to be my variable with that magic number that I had a minute ago, 2. So x plus 2 all squared, and that's the entire left-hand side factored. On the right, I just add the negative 5 and the 4 to get negative 1. From here, I'm going to go ahead and clean up, and then I will solve the quadratic. I can start by square rooting both sides, and on the right-hand side, I do need the positive and negative options. So I have x plus 2 equals positive or negative square root of negative 1. Now, if you've been working with imaginary numbers, you know that the square root of negative 1 is I. So I'll go ahead and write this as positive or negative I. Now, I do need to subtract 2 in order to isolate my x, but I have 2 terms over on that right-hand side. I have a positive I and a negative I. So let me split this up into 2 separate equations. That way I can solve with a positive I and the negative I as 2 separate cases. Now I subtract 2 from the left and the right, giving me x equals, I'm going to put my negative 2 first and my positive I second. That's just standard for complex numbers. And on the second equation, I subtract 2 from both sides. And again, I'll put that negative 2 first minus I. So my 2 solutions, though they are both imaginary, are negative 2 plus I or negative 2 minus I. And that's it. Thanks for watching, and I'll see you next time. Bye.